Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own AI agent with the help of Gemini, and we are going to use here Raspberry Pi 4. Also we have our latest Raspberry Pi OS bookworm 64-bit version. So basically we are going to create our own AI agent which control servo motor. So before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we are going to create Gen AI agent, and we are going to control SG90 servo motor with the help of PCA9685 servo motor board on Raspberry Pi 4 using latest Raspberry Pi OS bookworm 64-bit version. Simple. So for that I have created a new repository. I will mention the link. You need to simply copy paste the link inside web browser, and I am accessing Raspberry Pi desktop using VNC server. As you can see, this is the VNC server on Windows 11 machine. I am accessing with the help of real VNC on Windows machine. Of course you can directly connect the Raspberry Pi 4 as a desktop and you can run the code, but right now I am accessing my Raspberry Pi 4 on Windows machine using real VNC. So this is VNC, and as I mentioned, I will mention the code for today's project. Simply copy paste the link inside web browser, then go to the code and click on download zip. It will download our zip format repository. As you can see, we successfully downloaded. So let's just minimize all these things, go to the file manager and go to the downloads. This is what our repository. Right click on extract here. It will extract our repository. Right click, cut it, go to the home, and then just paste it our repository here. So this is what our repository. Inside that I have mentioned all the files which we want. So first, how to connect PCA9685 board with the Raspberry Pi 4. So for that I have mentioned two images. So let me open the image which is our PCA9685 board. This is what our PCA9685 board. Simple. Let me make zoom in. I hope you all see clear, because we want here the pins for PCA9685 board. So I hope you all clearly see that this is what our pins, and then we want our Raspberry Pi 4 GPIO pins. So let me open Raspberry Pi 4 GPIO pin. So this is what our Raspberry Pi 4 GPIO pin. Let me make like this way, and then this is what our PCA9685 board, and this is what our Raspberry Pi 4 pins, the GPIO pins. And I have mentioned how do we connect all the pins with Raspberry Pi 4. So for that I have mentioned this one text file which is PCA9685 pin Raspberry Pi. So pin Raspberry Pi, just open with the text editor, and I will minimize the main file manager. Simple. So I hope you all clear. This is what our board, PCA9685 board, and this is what our Raspberry Pi 4 pins. This is what our Raspberry Pi 4 pins. So now first pin from PCA9685, which is the V plus. As you can see, the V plus. So V plus we want to connect. As you can see, the V plus inside the text file I have mentioned. V plus we want to connect with the 5 volt of our Raspberry Pi 4. So on Raspberry Pi 4 we have pin number 2 and pin number 4, the physical pin number 2 and pin number 4 charged with the 5 volt. As you can see, the 5 volt. So we are going to connect this V plus pin to Raspberry Pi 4 GPIO pin on either you can connect with the pin number 2 or you can connect with the pin number 4, because both of pins charge with 5 volt. Then we have VCC. As you can see, the second pin from PCA9685 board, VCC. So VCC we are going to connect with the 3.3 volt. Here it is. As you can see, I have mentioned the VCC. So VCC we want to connect with the Raspberry Pi 4 pin number 1, this one. So because this charge with 3 volt, so VCC connect with pin number 1. pin number 1, as you can see, the 3.3 volt, this one, pin number 1. So V plus connect with the pin number 2 or pin number 4, then VCC connect with the pin number 1 for 3 volt, done. And then we have here SDA, the third one pin, the SDA. So SDA we want to connect with the GPIO2 pin number 3. So GPIO2 pin number 3, this one, physical pin number 3, GPIO2, and here you will see the mention SDA. So this SDA PCA9685 SDA pin, which is the third number pin, connect with the Raspberry Pi 4 physical pin number 3, GPIO number 2 and SDA. And then SCL PCA board pin number 4, SCL connect with the physical pin number Raspberry Pi 4 5, as you can see that 5, and the GPIO3, here you will see there is a mention SCL. So SCL connect with the SCL pin, which is the physical pin 5 number GPIO3, SDA connect with the SDA physical pin number 3 GPIO2, then VCC connect with the pin number 1 3 volt VCC, and V plus connect with pin number 2 or pin number 4. You can select one of them, simple, because both is charged with 5 volt. And then the ground pin, we don't want to connect this pin, OE pin, there is no need to connect OE pin. So SCL then directly connect ground. So ground connect with the Raspberry Pi 4 ground pin. So you can connect either with the pin number 6, because pin number 6 is also ground, or you can connect with the pin number 14. Simple. So ground connect with the ground pin, then SCL connect with the SCL, which is the pin number 5, physical pin number 5, GPIO3, then SDA connect with the physical pin number 3, SDA GPIO2, then VCC connect with the first physical number first pin, which is the 3 volt, and V plus connect with the 5 volt. Simple. So I have mentioned the connectivity, how you can connect the pins with Raspberry Pi 4 in text file. So this is what our text file. Simple. So this is how I have already connect the board with Raspberry Pi 4. So I have connect the board, and then servo motor, you have to connect the servo motor on PCA9685 board. So I have connect the servo motor as per this color code. So from servo motor we have orange pin, which is the data pin, then we have red color pin, which is the power pin, and then we have black color pin, which is the ground pin. So you have to connect like this way, first the orange color pin, and then the power pin, and then the ground pin. Any one of these pins, we have here 16 pin, we have here 16 pin. So because this we count as a 0, so we have total basically 15 pins. As you can see, we have 15 pins, but I have connect the servo motor with 0, this one 0, first one. Simple. I hope you all clear. So we have done with physical connectivity. I have connect the servo motor. So let me close here, and this one also. Now our next step, we need the packages. So inside repository I have mentioned requirements.txt file, as you can see, requirements.txt. So before we move to requirements.txt file, let's just say if you install completely fresh version of Bookworm on your Raspberry Pi 4, so first you need to run this command. So just open c.txt as a text editor and copy this command, copy it, open terminal, because I have already run the command, but when the installation is completely fresh, so open c.txt file, copy the command, and then just paste it and then hit enter. Because I have already run, so that's why it said there is no such a file, but fresh installation you have to run this command, which I have mentioned in c.txt file. Simple. And then now we are ready, and we will run our requirements.txt. So the repository is basically inside our home. So if I run here ls command, this is what our repository, as you can see. So we will go inside the repository, and then we will run our requirements.txt for our packages. So cd raspberry and just hit enter, ls, and we have here requirements.txt. Simple. So for requirements.txt, I hope you all see clear. Sudo space -r install and requirements.txt, then just hit enter. Sudo space install, let me check here. Sudo space pip3. I have forgot to mention here pip3, that's why there is error. So sudo pip3, let me clear here screen. We will start freshly. Clear. Sudo pip3 space install space -r then requirements.txt. This is what our file name. Just hit enter. It will install the packages which we required for this project. It will install Adafruit Servo Kit package. It will install LangChain because we are going to create our agent. So LangChain, then LangChain Gen AI package. It will install all the packages which we required for this project. Done. So we have successfully installed our packages. I have already run the commands, so that's why it says the requirements is already basically satisfied. Done. So we have done with package installation. Now we will move to our code. So test.py, as you can see this test.py, just right click, open with the Sony Python IDE. It will open our code like this way. Let me close here assistant. So this is what our code, friends. From langchain.agents, we will import initialize agent. Then langchain Google Gen AI. This is for our Gen AI, means this is for our Google agent Gemini. Chat Google generative AI. Then langchain core tools, import tool. Then this is what our servo package, Adafruit Servo Kit. The board which we are going to use here, we are going to control the board using this Adafruit Servo Kit module, PCA9685. That's it. And then time, import sleep time, and then import RE. Then this is what the function control servo. This is what the function for controlling our servo. And then kit, first kit is equal to our servo kit, and the channel, how many pins do we have on our board? 0 to 15 means 16 pins. So 16 here it is, as you can see I have mentioned the 16 channels. So channels 16, we have 60 channels board, PCA9685, as simple as. And then this is what our tool. So tool which we are going to use, of course, control servo. So this is the function. This is the function for controlling the servo. This is the function for controlling the servo. I have mentioned the name, which is control servo, and the command. So command is basically our user prompt. Basically we are going to create here a chat bot. So we will chat with our AI, and the command it will take and it will act as per our command. Simple. So this is what our servo control code. As you can see, angle is 0 to 180, as simple as. And because we connect our servo to first channel, so I have mentioned here a 0, kit.servo. Let's just say if you connect the servo motor with channel 2 or channel 1, you can simply mention here 1, 2, or let's just say 3, or let's just say 6. This is just a channel. 0 is basically the channel. Which channel you connect the servo? I have connect the servo with the first channel, means the 0, first channel. Then we have 1, then we have 2, then we have 3. This is how we count a 15, or let's just say if you go with the 0, so we have 15. If you count as a 1, so 1 to 16. Simple. So I have connect with the first, which is the 0 channel, then first, then second, then third, then fourth. This is how our board, 16 or 15 channel, let's just say. So that's why the 0 is basically the channel number. I hope you all clear. The 0 is basically the channel number. So kit.servo and the channel number, in your case it may be 14, it may be 3, it may be 5, it may be 6, whatever. So I have connected with the 0, so I have mentioned 0. And then this is what our angle. That's it. And then this is what our LLM model, which is Gemini 2.0 Flash, the latest model. We will use here latest model. And then we have our temperature. This is what our LLM. How do we use the agent? How do we use, or how do we create the model to initialize? I have mentioned here AI model initialization. That's it. And then temperature and all other things. Here we will mention our API key, and then we will create the agent variable. So we will use initialize agent from our LangChain. This one, from LangChain.agent we will use initialize agent. So initialize agent, and then we will use our tool. So our tool is basically our function, control servo function. Simple, control servo function, control servo. And the LLM is basically our LLM. Done. Then the agent type, OpenAI function, or you can mention any name. And then verbose is equal to true. Verbose is equal to true means it will show the backend process, what it is thinking, And then we have our while loop, and this is what our prompt, user input, and this is what a user input. If it is we mention the exit or quit or stop, then our AI will respond as a goodbye. Simple. And the response is basically this agent, because this is what our agent along with the tools and the LLM. Simple. It is as simple as. Now we need our API key, so I will open first the API key website. So friends, I have opened ai.google.dev. This is what our API key website, Gemini API key. Then get Gemini API key, click on it. And here I have already created one API key, so I will remove that one, create API key. I will create the new one and select any project, create API key, and it will generate the API key. Copy it, and we will save our API key. I have created a desktop here. I have created the file, which is the new. Right click, text editor, and then just save the file. Done. Simple. File, save it, and we want to close our API key website. Close it, close, minimize, and copy the key. Copy it, open Tony Python IDE, and here we will, here API key, as you can see in LLM. This is what our LLM. So here we want to paste our API key. Done. Now let's just save the code and run the code. So I will make like this way, because I have here my USB web camera which I have started, so you will get the idea. So here it is, as you can see, AI servo chatbot started, type exit to quit. So here we want to first ask the query. So how you can mention your prompt? So I have mentioned the example in the code. Here it is, as you can see, example. This is the queries you can ask. Simple. So I will make like this way. I hope you all see clear. This is what our Raspberry Pi 4 VNC server with our AI agent, and then I have here our web camera. So it will start my web camera. Then you can see lively. We have here servo motor. As you can see, SG90 servo motor live. So let's just say first I will mention the normal angle, means we will go with the normal query. So let's just say go to 50 degree, hit enter. As you can see, it thinks how it's proceed. I need to move the servo to 50 degree. Action control servo. Action control servo means control servo is our tool, which is our basically function for controlling the servo using servo kit module, Adafruit servo kit module. We have here PCA 9685 servo motor board. Simple. So the servo motor is basically move. So let's just say I want to move my servo at the 180 degrees. So I will mention the prompt for AI or agent. Let's just say servo move go to. Let's just say go to. This is how we want to ask the queries. I have mentioned here example. Simple. Go to 180 degree. If you hit enter, watch, it's go 180 degree. then let's just say go to 30, go to 30 degree. As you can see, the servo move to 30 degree, then move between 15 to 100. So let's just say we will mention like this way, move between 50 and 100. Hit enter. So what is the action? I need to instruct the servo to move between the angle 50 and 100 degrees. Control servo, move between 15 and 100. Servo move to 15 degrees. Now what we will do, we will mention the query like this way, move servo from 0 to 180 5 times. So let's just say move servo from 0 to 180 5 times, 5 times. If you hit enter, now watch, it will think. As you can see, it says I have to move 5 times, so it moves one time first time. So now here it is, as you can see, now it says we have to move at the 4th time because it's already done with the 1, so 4. Now it says the 3 times. So agent is basically thinking how many times I have to move right now. So here we have done with the 3 times, and you can see the servo is moving, and then the 2 times and the 1 times, and then the chain is completed. Here it is, as you can see, the message is basically finished chain, means agent is thinking what he want to do, using our tool, and our tool is our own servo function for controlling the servo motor SG90 using PCA 9685 board. Simple. Now we will increase the 5 with, let's just say, 10. So again same query, move servo from 0 to 180 at 10 times. Hit enter. Now watch, it will think 9, then 8 times, then 7 times. Watch, and watch here also 10 times. Now it will say I have to, here it is, as you can see, the 9 times. Move servo from 0 180 9 times, 8 times. I need to instruct the servo move from 180 10 times. Now action 9 times, then 7 times. Here it is, as you can see, the action 7 times. It means our agent, it has the tool. He is using the tool and he is thinking what he want to do, friends. So this is the perfect example for the AI agent. You can clearly see that the LLM, or we can say that our AI is thinking what he want to do as per our user or as per our prompt. Simple. So I have mentioned the full code. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.